Today, we want to talk about the signal. What is a signal? Do you have any idea about the meaning of signal? Is there anyone who can define the signal or explain the signal? We can say that a signal is a function of independent variables that convey information about the event or phenomena. Okay, I repeat it. Please don't forget the meaning and define of the signal. The signal is a function of independent variables. What kind of variables? We can say time, distance, temperature. All of them are independent variables. So we say that signal is a function of independent variables that has some information or convey information of what? Of a phenomena or event. Convey is sending something from one point to the another point. This is the meaning of convey. Okay, so this signal can be a audio signal, can be video signal, can be speech signal, image signal, and so on. We have so many different types of signals in the digital form that we will use them. Now, what kind of signals do we have? Or actually, I want to talk about the types of signals. Generally, in this case, in our course, the main types of signals is divided into two parts. The first one is analog, and the second one is digital signal. What is the meaning of analog and digital signal? Do you know the meaning of analog and digital? Is there anyone to explain it? What is the meaning of analog? When we talk about the analog signal, what did we want to say? In fact, we say that the analog signal is a signal that varies continuously during the time with different values in amplitudes in any time of instance. Okay, the analog signal is a signal that varies or changes continuously during the time, that at each time we have different amplitude. At this time we have this value for amplitude, at this time we have this value, this time this value, and up to the end, and change continuously. But in the digital signals, we have only two different discrete values. For example, in this figure, we have only 0 volts and 5 volts as a values and amplitude of this signal. In the digital signal, we have only two different discrete values for amplitude during the time. And in binary form, we say these two different values, 0 and 1. Actually, the lowest value of the signal is called 0, and we suppose the highest value of the signal as 1. In this way, we can say that this signal is a digital signal that varies between these two different discrete values, 0 and 5. In electrical and electronics engineering, in the digital form, normally we suppose that 0 volt is called 0 in binary, and 5 volt is 1 in binary system. Okay, here I explained all of these things that I talked before in the previous slide. As you see here, we can say that analog signal are waveforms, that sensors produce these signals. We will see that what is the meaning of sensor and how the sensors produce the signals, actually analog signals. And these signals vary smoothly over time, such as sinusoidal waveforms. As your friend said, that the sinusoidal waveforms are analog signals. Okay, in the case of digital signals that used in the logic circuits and computers, we have typically two discrete values, and these different values encoded in the binary logic with level 0 and 1. Now, here I want to show you two different types of analog and digital signals. What is the difference between this analog signal and this one? The difference between these two signals is difference in the frequency of signals. This frequency, the frequency in this signal is lower than this one, and contain a 1 frequency. This signal changed with 1 frequency, and the frequency at this signal is high, and also with different type of frequencies. And the digital form of these signals also contain the frequency. As you see here, this signal changed with the same frequency of this analog. And at this signal, we can also see that this duration is higher than this one, and again continues like that. Because in the analog one, we have two different actually frequency. Now, what is the meaning of frequency? Frequency is the number of repetition of periodic process. This is a periodic process that repeats during the time. In other words, we can say that frequency is a number of cycles or vibration per unit of time. Look at here, this is a sinusoidal waveform. We start from here and pass through the curve and reach here. Then after that, if I start to move, I can say that the same thing or the same waveform is repeated. Everything from this part up to this part is the same as this part up to this part. It means that this section is a cycle, of signal, which is repeated during the time. And we say that the number of this repetition, the number of this cycle in a unit of time, it means that in 1 second, is the frequency. For example, in this example, suppose that this is 0 second and this is 1 second. In unit of time, this signal repeats 2 times. How can I find that? Because this signal during the time has 2 cycles which is repeated. It means that F is equal to 2 cycles per second. This cycle per second is called hertz. Now, you can see here 3 different frequency levels. This is a low frequency. It means that the repetition in a unit of time is low. This is medium frequency. It means that the repetition in units of time, this is so important. We only talk about the repetition in unit of time, not in the all of the time. And this is the high frequency. As you see here again, the frequency at this signal is higher than these two ones. We have another terminology called period. What is the meaning of the period? In period, we can say that the period is the smallest time interval required by a wave to complete a wave cycle, to complete one cycle. The cycle here in this signal can start from here up to here, or can start here up to here. How can we select the cycle in a signal? You can start from every instant of time and start to move. If after some time you reach to the same place of the waveform on the curve of the signal, it means that you pass one period. So I start from here and move on the curve of the signal and reach to this point. After that, the signal is the signal like that. This section of the signal is like this section of the signal. It means that this duration is our period of signal. In this section, T is 0.5 second per second. And interestingly, the relationship between the frequency and period can be calculated using this formula. We can say that period in second is equal to 1 divided by F. F is frequency in hertz. And vice versa. F is equal to 1 divided by T. It means that the inverse of period is frequency, and the inverse of frequency is period. Now, I want to talk about this system. What is the system? In fact, we can say that a set of interrelated components or elements which are working with together toward some common objective. Please notice to these terminologies. A set of interrelated elements. The first one, interrelated, relationship, interrelated means that two elements have relationship with together internally. This is the meaning of interrelated. Interrelated elements. Second one, working with together. The third one, have a purpose, have objective. What is the meaning of element? Actually, everything in our world can be say an element. A part of something is an element. This is the system. Okay, this is this system. A digital device, a smartphone. Okay. Now, inside of the system, the microphone is an element. The speaker is an element. The digital PCB, printed circuit board, inside of the smartphone is an element. The transistors and ICs that are used inside of my device is elements. All of these elements connected with together, all of these elements inside of the system connected with together and work with together to some common objective. Let's continue. Suppose that this is our system. These ellipse, square, triangles are the elements of a system, and these arrows indicate the relationship between these two elements. According to this arrow, we can say that this triangle element is related with these ellipse, and similarly the other elements. Okay, so I said that this is element and these arrows are relationship, and generally this circle can be supposed that our system. Okay, let's now we understood the meaning of the system. Let's talk about the digital system. The digital system actually have a prominent role in today life, in our lives, in our age actually, because most of the devices are digital, like computers, like smartphones, and all of them. So we need to know the characteristics of these digital systems. In fact, digital systems in our world are used in communication, business transaction, traffic control, medical treatment, and all of the other majors in the world. So this digital system have some characteristics. Early digital computers were used for numeric computation. Every digital computers that we are using them used for numeric computation. We say that the signal in electronic digital system used with two different values. The first one is 0 and the second one is 1. This 0 and 1 is said binary. Suppose that you want to send a message, for example, hello. Via your smartphone to the another one. What happened how does your smartphone send this hello? We said that our digital system only understand two values, 0 and 1. My smartphone and my computer cannot understand the H, E, L, O, and other alphabets, and also cannot understand 1, 2, 3, 4, 5. How can we send this information from one device to another device? Using binary codes. What is the binary codes? The binary codes are the codes that is a collection of these zeros and one. For example, 0, 1, 1, 0. This is a code. 1, 1, 0, 0. This is another code in 4 bits. Each of these 0 and 1 is called bit. This is also bit. How many bits do we have here?
4 bit.
4 bits. 1, 1, 1, 0, 0, 1, 1, 0. How many bits do we have?
8 bit.
8 bit. This is called 4 bit code. This is called 8-bit code. And these codes contain a meaning. Each code calculated for the one purpose. For example, the code of H in one of the codes is ASCII code, okay, which is used in the computers. The code of H is like that. I only say for understanding you. 1, 4, 1, 1. The E is, for example, I don't know, 0, 1, 0, 1. L, 1, 1, 0, 0. Again, L, 1, 1, 0, 0. O, 1, 0, 0, 0, 1. Okay? This is the O. This is the L. This is the L. This is the E. And this is the H. Interestingly, if you write hello in your smartphone, the devices, analog to digital devices, convert all of the alphabet or other signs that you use them, dollar, question mark, sharp mark, star, plus, minus, divided, slash, backslash, all of them, and digits. All of them has a code, binary code like that. Now, this binary code we together send to the device. The computer understands this one. 1 0 1 1 0 1 0 1 1 1 0 0 1 1 0 0 1 0 0 0 1. The computer understands these digits, which is called binary code. Our device send this binary code to the another device, and in the another device is code. Actually, during this process, this code, which is a data, is encrypted encoded, compressed, then sent to the another device. In the device, I receive this code 110101 1100 1100 1000. Actually 100, this is the one extra because we have to have 4 bits. Now our device divided this code. This is the decode, meaning of decode. Divided this code to the 4 bits because our device knows that this system is used for binary, for ASCII code, for example. And now our device understands that 1011 is H, 0101 is A, 1100 is L, 1100 is L, 1001 is O. So my device understands that hello. And using actuators, the monitor is actuator, shows you the hello in the monitor. When I write hello, I use sensor. This sensor convert to the digital system, send it, and the another device understand this code that is the hello. Generally, these digital systems work using this method. Generally,